Alright, hey everybody, we're doing Object Tracker Part 3. This is a video of 3 parts, 1, 2, and 3. So we have Object Tracker data, and we had that where we were tracking the basketball, and we're able to get its position in X and its position in Y over time. If you somehow ended up here but you haven't done look at the other parts to make more sense of what's going on here, please go check out our previous video so you can kind of get what's happening. So I already have the data uploaded and shown here, but if you didn't have yours uploaded yet, let me just show you what it would look like on your end probably. So it would be a blank sheet, but if you go ahead and hit up the top bar here, go to File, and go to Open, it might be different on your computer, but it'll probably be under, you'll want to hit Upload, hit Browse, and more often than not, it'll probably be in Download somewhere for you. Or if not, I mean, if your data is gone for some reason, you know, it would be unfortunate if it was, but you could go ahead and go back to the tracker and go ahead and analyze the video and go through that whole process again. And if you want to, in case you forgot how that process works, you could probably check out the first video of this series to get through that, to get data again. But you know, there's no harm done. If you lost the data, that's totally fine. You can recreate it. You know, same process will come out, and then thanks to physics, the outcome should come out more or less the same with your new data set that we'll get through this in this video. So let's go back to our data set here. And also the data file name should be data.csv, or if you did a bunch of different data sets, it might be like data1.csv or data2 to 10, however many times you did. But yeah, let's just, you know, we always talk about the data. In my last video, I talk about the data. It's always good. Just look at it and just see what you have, what information is given to us already. I may be like, I've said this a lot, I said in the previous videos, but you know, let's just get accustomed to what we have with us. So we have 3 columns. We have time, which was taken in seconds. We have the position. This is tracking the basketball, so we have the X position, and then we have the Y position of the basketball. One thing to remember is that in the video, we had a 240 frames per second video, and so the times here, these numbers represent each one we iterate through 1/240th of a second. And so, you know, we got pretty good tracking, and that's why these values get really small as we progress through time. And then as well, the reason for object out of range, if you remember, is that in our tracker, let me move through time. In our tracker, tracking only begins once it enters the green rectangle within the frame. And so obviously we started tracking data as soon as we did the analysis, so there's a few seconds or a few fractions of a second where we have no data because the basketball isn't in frame. And so that's why we says that object out of range. And then as well, we're just gonna open up these columns just so they don't leak into other columns. Just looks nice, aesthetically pleasing, makes things cleaner. Alright, so then to get familiar with the data, this part here is once the object we're tracking, the basketball, makes it into frame, and this is where we have our first actual data point with position for X and position for Y. So, alright, so we familiarize ourselves again with our data. You know, we're following this activity. We're just going to go back to it, and we're going to calculate the velocities for X and the velocities in the Y direction. Let's go ahead and make columns for what we're calculating. So we're going to calculate velocity in the X direction, and we're going to go ahead and label that Vx, and then the velocity in the Y direction, and we're going to go ahead and label that Vy. Just so we know, you know, if you do some analysis or you have to leave midway through this video, you kind of know what these represent here, or have an idea of what the numbers in this column will represent. And so the second thing, we're going to talk about mother sheets just to like be able to calculate what we want. Is so velocity, it's the change in position over the change in time. And you know, when you do things on paper, there's no like you get what you're doing. But on Google Sheets, you got to tell it what it needs to do this calculation. So in order to have a process where you're able to plug in numbers to create a function and give you the output that you're looking for, you always need to start with an equal sign. If you don't, Google Sheets won't know what you're telling it to do or what's happening. So in this case, so now referring to the calculation that we want to do, we want to calculate the velocity in the x direction. And that's the difference in position over the difference in time. And so, actually we don't want this cell. What we want to do is you want to hit, not the very first row where we have data, but the second row. You want to go ahead and also the reason why we're starting at the second row, the first one we'll address in a later video. If you're familiar, we'll talk more about it, but we're doing what's called the central difference method. We'll have a separate video that talks more about it and other methods like the forward difference method as well, but there'll be a different video for that. But we start here in the second row and go ahead and put that equal sign. And now it's the difference in, we're getting velocity in x direction, so it's the difference in the x position over the difference in time. We're setting up a function and we have our equal sign set up. And then we got the parenthesis just so we don't get confused on just when the math is happening. You know, PEMDAS, parentheses come first. And so we're going to have to put a parenthesis in. And then we're doing the difference. Remember, the difference in the x position over the difference in time. And so we're going to, in this row, in the second row here, we're going to get the x position that's in the very next frame. And to be in the very next frame, that's the third row. And remember, our data here is the middle column for x position. So so it says this B40 here refers to this cell, and this cell represents the x position in the very next frame. And now we want the difference. So then we're going to subtract, and then we're going to get the position in x in the frame right before this. And you go ahead and click that. And that same thing happens here. Now it's referring to this B38. This B38 points to this here and refers to this value here. So in essence, for B40, you know, that's being represented by 0.7285. This difference is actually pretty small, but they're representing the numerical value that's in this cell. And then, sorry about that, misclick. And then B38 is representing the numerical values that are within this cell here. So all right, so now we got our change in position for x, and now we need to get the time, the difference in time. And so same thing here. We're going to click the time here, 840, and this is representing of what the time is or will be in the next frame. And then we need to get the previous frame. And then we hit 38 here. And just reiterating again, we're not doing like 840 minus 838. We're doing the numerical values that these cells represent, which are indicated over here. And Google Sheets is nice enough to color coordinate just to make it clear what it's referring to, right? So hopefully the color coordination comes out pretty clear in the video and on your end as well when you do this. Alright, so now we have this set up, and you could go ahead and hit enter on your keyboard, and it made 0, but if you look at the values at the top, they were the exact same. And it looks like Google here, there's this nice autofill. This may or may not be occurring on your computer. It might depend on your sheets or whichever, but this is what we're going to want to do next. But you could go ahead and answer if you want. I won't, just so I could just explain the importance and like the tricks you could do with Google Sheets, just because maybe this might not come up for you next time and then you'll be confused. And so we're going to go ahead and hit no on this, just so I can, for the sake of for learning. So okay, so now we have the Vx, we have the velocity in x for this time here, due to getting the change in position over the change of time. And now to get for the next time, you know, we could just type it up again as we did. We could click all the cells. You know, I'll do it just for, you know, for fun. Oh, that's actually the wrong cell. You know, we go look at the next frame position, the difference, go this one. You know, I'm getting already tired. I'm getting short of breath. Just too much clicking. Ah, my wrist. Nah, I'm just kidding. But then we get the difference. And enter. Nice. And then now I just have to do it. How many rows we got here? Start at like 40. You know, I just want to type this another, oh my gosh, another like 250 times. I don't know. That's going to be a long video if y'all watch me do it. So we're going to make the cut right now. Nah, I'm just kidding. So there's tricks here. There's tricks on Google Sheets. We ain't got to do that. So there's two ways. One way is you could go ahead and just drag this corner and you just go all the way down, and it should auto-fill for you, so we don't need to, you know, hurt ourselves, like drain our mental energy. And there you go. And a way to see if it did end up doing what we said is if you just click one of these values, you'll see the function here. And you can also double click, I believe. Yeah, and then we could see the color coordination, and it's doing exactly what I said to fill the very first value at that time step. And so that is one of the ways to do it. And now I believe another super shortcut. We're just gonna shortcut if you want to undo something without finding the undo button somewhere is you just on your keyboard you hit Control Z. It'll undo whatever the last thing you typed or did on Sheets. So life hack, you know, keyboard shortcuts, fluid, it's quick. You ain't gotta like use the keypad or your mouse. And I believe another method was if you hold, was this Shift? Yeah, if you hold Shift and you just go all the way down, sorry, to something I didn't highlight as well is we need to go to the very second last row. And as I mentioned earlier, this is because the method we're using is called central difference. So how that works, we can't know this value for what Vx is. There will be a separate video that goes into why that is. But for now, just go to the second last row, highlight it, and I believe it should be Control D, and it'll fill in same thing as the other trick. It should fill in the formula for us, and then you see that it's also now calculated the velocity in the x direction for us following the function that we gave it. And then I'll just show for clarity, it did exactly what we wanted it to do, where it went a time frame forward and time frame back. And then same thing with those values there. Okay, so we've done it. I've shown you some nifty tricks, but we got the velocity in the x direction all filled in. And now we got to do the very same thing, but now for the velocity in the y direction. So we're going to double click the equal sign, and remember this is to declare, I was saying function earlier, but also might be easier to declare an equation. So it's going to do work for us. So this here, set up our equation. And now, same process, right? The difference in position over the difference in time. In this case, we want velocity in the y direction. So we're going to go ahead and do the difference looking at the next frame here. So it should be C40. Get the difference, and we're going to look at the frame right before. Get this. And so now we got our difference in position in y. Divide that over the difference in time. Oh, I forgot my parenthesis. Put the parenthesis there. 40. And we're getting the difference. Then we look at the time frame right before. And boom. And then go ahead, hit enter. And then nice. So already Google's really nice. We got this. I'm gonna go ahead and just check mark this. Or who y'all want to see the trick at home? Alright, I'll show you the trick at home. It's cool. Just in case you forgot. Alright, we're gonna do the highlight the corner one. We're just gonna drag it all the way down. Again, remember this is one of two ways, but I'll just go ahead and do this one. And as I stated earlier, go to the second to last row. I will explain why that is in another video, but if you just want to hit on Y, like let's say we did go to the next one, let's drag it down. You can see these numbers are drastically different, and if you double click to see the function, we are out of data, so there's no next frame to grab anything from, and so it really just has information about the previous frame. And so Google just, if there's nothing, if it's blank, Google just says it's a 0, so that's why it's still giving us a value even though there isn't data. Well, we'll talk more about the central difference method and the logic behind it, but this is like a clear example on why we don't go to the very last row. All right, so we've gone ahead and now we calculate both the velocity in x and the velocity in y. And now the next thing we need to do, hopefully you're following the activity sheet, is we want to plot the velocity in y again versus time. So back to our data, and just in case you forgot, we'll go back up. These column names are important so we don't get lost. Is that we want this E column here, which is representative velocity in y. That's the calculation that we did below. And against time, which is our A column over here. And so we want to plot time versus velocity in y, or if you want to go by these column names, we want to plot column A against column E. And so, you probably what you would be thinking as well, there's no data here, right? Because of the tracker, it was never in frame, we weren't getting any data. So what you might think is, which is fine, it will probably still end up working, but go to the data where we actually have numbers and plot it. And so you can go that route if you wanted to. You would just click and drag all the way down. I won't go all the way down, and then for column E, you can hold Control and then drag all the way down as well. And then go ahead and make a plot that way, going Insert and then going Chart. But that's it's a little long. Maybe this is just an example problem, but what if sometime in the future you're going to have a million rows, just like a bunch of data, and to afford to drag all the way down, that's kind of inefficient, just efficiency time wise, right? So the shortcuts, we have the technology, so a quicker way to go about it, and Google Sheets will be able to figure it out for you. You can just hit column A. I'll go up so you can see what we're doing. Column A, and then hold Control and then just hit column E. So I know I did mention earlier there's no data here, but Google won't give these zeros. They'll just ignore it. They'll just assume there's nothing here to plot, so they'll go and actually start where there's values in both E and the A column, which is this row right here. And so once you have those both highlighted, go ahead and go to Insert, go to Chart, and then now we got a plot. And then as well, Google just auto sets up a line plot, but that isn't a good representation of our data. And we want to do a scatter plot, which is this right. Oh, I'm in the frame. Actually, let me fix that for y'all. If you double click on any plot, it'll open up all the properties and things that we can mess with. And as I was stating earlier, sorry about that, we don't want a line chart. A scatter plot would be better representative of the type of data that we have. And it might be hard to see because we have a lot of data. This looks like a blob mess, but if you hover over it, it does say scatter chart, which is what we want. We're going to go ahead and edit these and give them their respective units. So let's see, is it nice? Oh yeah, it looks like we could just double tap on the label and it'll open it up here on this side to make those edits. And so you could keep T, or you could write out time, whichever is your style. Sure, I'll just write out time. Let's change it up. And then you could write out what the unit is, but I'll do shorthand. I'll put S for seconds. And then similar here. If you don't want to double tap it, let me go back. You could just go into this chart right here and it'll give you the options. And so we want the vertical axis. Vy is good for velocity in the y direction. And then something to remember I didn't mention is our in the video we have a meter stick for frame of reference, and so our units for position are in meters, and then the time is in terms of seconds. So then our units for velocity must be meters per second. There we go. Alright, so now we have both these axes labeled properly and they got their units, so we could kind of make more sense. And units are just important. Just want to reiterate that, right? If you're making a presentation and showing this to someone, showing it to your professor, other peers, units matter a lot, because then if for some reason this was like centimeters per second, but you mislabeled it or didn't even know, it tells a different story. So it's good to always have units. Something else that might be hard is the font. It's a little small. It's probably small for y'all watching this video. So same thing, under the same properties and settings that we have, you can go ahead and make the font size. So let's go 20. Yeah, that's pretty clean. And yeah, so there we go. Now we have their larger font. You can make it as big as your heart desires, but as long as it's still clear. The title, just to show we can do it, I'll go ahead and change it to something larger. And also too, aesthetically, what if we can change it if in center or on the right side. Let's go ahead and center it for y'all at home. Nice. Okay. And you got font too if you wanted, but Arial's just fine for us. Alright, now we've made our font bigger for our title and our labels. And if now our axis numbers values don't look as nice either, so we'll largen them up. You can go ahead and click on them, or if you don't want to go that way, remember you have everything to customize here. So we could go horizontal axis, and then we'll have our font labels there as well. So we got 18, seems pretty reasonable. And now I just unclick this and hit vertical axis. It's representing these labels over here. It's always good to have them the same. Referring back, it's 18, not 20. Just keep things consistent. There we go. Alright, nice. We made the plot. Now we're just gonna we'll refer back to the activity, but I'll get to what I want to ask. But let's just look at the plot and think through if it makes sense to us. Like, is this a reasonable thing for the velocity to look like as it was changing over time? So, alright, and we have our plot all made up, and if we look at it, it's pretty nice. It looks like it's a pretty linear downward slope. And so, does that make sense? Remember, this is the velocity in y. And so, let me just refer back. Let's just look here. So, so remember, we're in y position, right? And so when our very nice, big baller here threw that ball up, it went up first, right? So if we're moving something up, that would mean it would need a positive velocity in y to be there. So it needs to be positive. But as well, due to gravity, it slows down and then it wants to come down. And so you would have a change velocity that go in negative. And since gravity is the only thing acting on it, we can deduce that it is perfectly reasonable to expect that we first started off with a positive velocity because the ball was going up, but gravity is acting on it, slowing it down, and thus this change velocity was was going faster than it was going down in y position, so the change of velocity should be negative as it's going. Another thing to note as well is a velocity at some point hits 0. And now this does make sense because there's a point where it's no longer going up, but it's not going down just yet. That's that. You're probably able to figure out just given the motion, but there's some point, you know, maybe it's somewhere here. I'd like the precipice at the peak, and there's no loss. It's not moving up or down. It's 0. So yeah. So what's happening? Velocity starts positive and it's going up, but gravity's acting on it, and so it's getting less and less positive. And then there's a point where it hits 0, and it's in the air, but then gravity keeps acting on it, and it brings our ball down. And so yeah, a linear slope is what we would expect, a linear negative slope. Let's see what our next step is. All right, so we got our data, and it looks like we want to fit a trend line. So now, how do we go about a trend line? So if you double tap, or if you just click on the data, it'll highlight it. But if you didn't want to do that, you know, you just hit customize series. It's just referring to our data. Then if you scroll down, there'll be a button right here. It says trend line. And then Google auto selects just linear fit all the time. So I didn't make that choice, but as we were talking about, linear does seem the right fit. So it looks pretty good. Visually, you know, blue on blue, I can't even see the trend line that's going through here. So we're going to work on some aesthetics things before I talk about the equation with y'all. So let's clean this up. So something to do is we go to the trend line here, and let's make it a different color. So these labels here under series here, you see that the customization only came out when we hit trend line on, so this stuff will affect how we're making our trend line look. And then we don't want it blue. Let's go ahead. Well, how's a black look? Sometimes you might need to test colors. And opacity, just how bold, how see-through is it. So we'll put like a 70. We'll keep it black, and all right, so it's a different color now, but we still see that the trend line isn't fitting through, and so now we need to mess with how just the data points, the scatter points, so mess with their colors. So we just scroll up, they'll be here. So what you'll want to change is the opacity here. So right now it's 100%, which means it's fully solid, so it's not letting anything that's behind it through. It's not letting any color through. So if we go ahead and lower this like a 30%, we got a lot of data. Yeah, we could type numbers too. You're not just fixed to these options that they give you. So if you want to type numbers, just try like a 25. Well, not 250. All right, so it's still kind of hard to see the trend line, but I've made this mistake before. Because I clicked on the data points, they're more highlighted and it looks more filled in than what it really is. So make sure to click away. And now you can see, we still see the data, but now you can pretty nicely see the trend line actually fitting through these data points. And you're not fixed to these colors. I just picked one, whichever feels clean to you, a clean setup. I don't think there's like a rule of thumb in the field, as long as you should make them different. All right, so we got that fit, and now we want to see what the equation is. So now it's easy to see the trend line. It sees that linear is clearly the best choice, and also it makes sense. All right, now to know the equation on Google Sheets, right here where it says label, if you just click on that, there's going to be a use equation, and then I'll have it represented up here, over here, and as it's called a legend, and it has a differentiate. This says the blue is referring to our data, which is the velocity y, and then it's saying that the red line here is represented by this equation, which is the red line in the plot. It goes all the way through our data. So in general, this graph is saying y equals negative 9.61 times x plus 4.66. So now remember, one, if we're saying y equals this y, it's referring to what's the variable in the y-axis. So for us, it's velocity in y. So this is saying the velocity in y is equal to negative 9.6. And now talk about this x. This x is representing the variable that's in our x-axis. But for us, that's time. And so in actuality, this equation is actually velocity in y is equal to negative 9.61 times time plus 4.66. So this will always happen when you make any plots. It's not unique to this experiment. So anytime you're doing a best fit line, always remember what variables is in your x-axis, because that's what this will represent, and what variables in your y-axis, as that'll be what's equal to this equation here. So don't forget about that. I'll always bring it up. But now we'll move to the glass board so we can see kind of what these numerical values represent. And we'll use that by looking at the kinematic equations. But yeah, we'll hop on to the glass board, so we'll have a cool cut and we'll show you. All right, so we've jumped to the glass board now, and we're going to write down the equation that I got when I plotted velocity versus time. You might have a different one, but you can still follow along. So how the Excel sheet told me what the equation was, it was written out as, okay. And now something I just want to reiterate some more is that the equation that Excel gives you, because it gives you something y equals in the x's, they're referring to whatever variable you had that represented the x-axis in your plot and that represented the y-axis in your plot. So for us, what it represented was, for our y-axis, it represented velocity in the y direction. All right, so there's a kinematic equation that this is identical to, so we can able to figure out what are these coefficient value here, what does that reference to, and what does this constant, what does that refer to? And so for our kinematic equation, it's, in this case, I'm going to specify it for the y direction because that's what we're looking at, but it would be v final, in, I'll do a y for y, the velocity, the final velocity in the y direction would be equal to acceleration in the y direction times time plus velocity initial in y. Depending on how you were taught, sometimes v initial instead of v sub I. Some schools do, they call it v naught, or like a 0, and that refers to the same thing as initial, but I'm going ahead and do vi, just it's a little more clear, but it's perfectly okay if you're used to a v0 or v naught, you could put that there as well. And so now it's kind of clearer, we can see what do these values mean, and so now we have an acceleration. So we know that the acceleration of y, we know it's due to the Earth's gravity, but now we actually know for sure its value. We're going to go ahead and write that out as this negative 9. So we have our values down, and one thing that's very important is you never forget units, because otherwise these represent nothing and they're just numbers. And so in our experiment, we know that we have meters and we have seconds, and so for our acceleration, we should have meters per second squared, and then for our velocity, we should have meters per second. And what we know, I'll write it out, but the true answer to the acceleration due to Earth's gravity, I'm going to write it over here on the right, and we're just going to call it a g for gravity, and it's negative 9.8. So when we calculate what the acceleration due to gravity was with our data set using the velocity values, we get really close to the true answer here. So I forgot my units here, meters per second squared, and now let's just calculate the percentage error that we have. And so I'll just write out the formula. So it would be, in general, to get the percentage, it's the true value minus the estimated or calculated value divided by the true value. And this will, and then we multiply by 100, and this will get us my percentage. And so I'm gonna go ahead and write that out here for the values that we have. 9.8 minus, I'm around 9.6, but it should still give us a pretty good percentage, and then minus 9.8 and times 100, and this comes out to about 2%. Alright, so for the data that I created, I got about 2%, which is really good, surprisingly, for the type of experiment that we did. And if you've been following the channel, been watching our videos, we kind of vary about getting between 5 to 10%, which is fine too. We're perfectly okay with when we got those estimates that we're off by that much. And you may be similar for y'all yourselves, but it's very nice to see we got an actually pretty good experiment done, and they got us as close as we did. But yeah, so if you follow this process, and you'll be able to calculate the acceleration for gravity based on when we did the line of best fit on velocity. You could do the same process if you do your own experiment, you get new data and everything. You will lead to a similar outcome. But so now we've seen how close we are calculating the acceleration of gravity from our data. But now we're going to pivot off and go explore the velocity in the x direction. So we're going to go move back to the laptop, and we're going to go work through that and create the plots for velocity in the x direction versus time. And we're going to learn some interesting facts about data and other interesting quirks that velocity in the x direction has. So I'll catch you guys probably in like 0 seconds. We'll talk in a sec. All right, we're going to have to go do the same process. Or actually, just in case, what if I'm saying that's not the next thing to do? We always go back, look at our activity guide. We already did step 5 on the glass board here. And now we're going to go ahead and do velocity in the x direction. I'll make the scatter plot, and then we're going to fit the trend line. So as we did before, we're going to hit column A. And something to note is, I say hold control and hit D, because it hits those 2 columns, but you might be wondering what happens if you do shift, because there are a lot of keyboard shortcuts that use shift and click or shift and that button. But we'll go ahead and do that. So I hit A, then if you hold just shift and hit D, it'll highlight every row between A and column, will highlight every column between column A and column D. And so in this case, when you hold shift, I have all this. I'll just show it. Maybe something cool happens. Sometimes you can do that in plot. It'll just be a little more work to clean it up to that data you actually want. But yeah, so yeah, we don't want this right now. But so we're just gonna delete this plot and do the method that will just highlight what we actually want to plot. So click column A, hold control, hit column D, which is what we want because we want the velocity in the x direction. And then go ahead, go insert. We're going to go chart. Oh, that's very interesting. We got, what is this blue? Time against time. So, I mean, this is good to know. So if this happens, so what's going on here is that Google, it may be because there's these empty cells here, these data points where there's no velocity in x. It may have thought that maybe we wanted to also see time versus time itself. So that's why there's this linear line here. And we could also know that, I'll zoom in so you can see, is in the legend too. It tells us what variable it's being against, or yeah, what variable we're looking at against time. So it's time versus time and dx. So this may happen. So look, even though our trick is faster, but at least with this it's still quick because it's an easy fix. But also something to note too is the difference between when we did velocity in y versus time is it didn't autofill our labels, because now there's like Google believe there's too much happening. But it'll be all right. We need to clean up our plot anyhow, so we'll get through it. So you go to setup, and then right here, these are the two different data sets that it's making this plot with. And so we're going to go ahead and hit the three dots, and then remove all series. I think just remove. All right. So now this is what we want. Now this is actually velocity in x. Oh no, this is times on the x-axis here, and the y-axis is velocity in x. This graph is pretty interesting looking, but before we get there, we got to clean the plot up to make it make sense to you and to make it make sense to the future you if you look at this plot, because right now this makes no sense, like what's going on. So we're going to clean this up. Let me make this a little bigger. I'm going to eat up our previous plot, but that's just so we don't get confused. Alright, so if you don't have these settings out already, go ahead and just double left click on the plot and they'll come out here. I'll show you. Just exit out here, you go ahead and double click this plot, and then all these settings come out. Alright, so first step, as I discussed for the last plot, this is making a line chart. We don't want a line chart. A scatter plot is more representative of the kind of data that we have, and it should be this one, and it'll have the label here. There we go. And now let's do some labeling. It looks like when we did that change, it actually put an X and a Y label here for us, but we need units. Units are important. But alright, so we're in the Customize tab now, and rather than clicking the actual things we want to edit, we're going to mess with them through the actual tab. They both lead you to the same place, but just another method that I'll just go through. So let's mess with first with our axis titles. So good, open that up. And remember, there's a chart here so we can work our way through. So we'll just start with the title. It looks like Google was already very nice and filled that up for us. But let's go ahead and make the font a little larger. As before, 30. Sure, we'll go 30. And then alignment, you could keep it however you want, but we'll just center it here. Oh, actually, and then we want to change our horizontal axis label T. I'll keep it the same as the last plot. You could keep it as T or write out time. I'll just write out time, and then make sure to put our units, seconds, and then the font is pretty small, so we're gonna make it bigger. Yeah, 20 looks nice, and then we're gonna go ahead and do the same to our vertical axis. Make the font like a 20, and then make sure we put our units. And as stated, all our positions we're taking in terms of meters, and all our time is in terms of seconds. It's meters per second. And that should be good to go. And Vx representing velocity in the x direction. So we got all those labels figured out. And then now we want to change up our tick marks. They're pretty small in font. So we want to go horizontal axis here, which will refer to this axis here, and get this font larger. Alright, so we have our plot. It's all cleaned up now. We got good labels, good sizing, got units, makes sense. And now let's go ahead and just think about our data set and like, does this plot, is it making some sense? And so remember, this is the velocity in the x direction. And so I'll just move to the actual tracker to kind of talk it through. Let me go ahead, get the tracking mode going. And so something to remember is that the only thing that acts on our basketball after it's thrown is gravity. And gravity should only be changing the y position of our ball. So as we're saying, gravity is only acting on the ball vertically, which made sense when we saw the linear plot, when we saw velocity in y versus time. But there's nothing acting on our ball horizontally in the x direction. And so the ball's only ever going this way And so its velocity should be constant the whole time because there's nothing else acting on it that would change its velocity. And so if we look back on our plot that we made, we do see that it's pretty constant. It looks like it's probably around 2. I will talk about this in a moment, but for the most part, there's not much of a slope and there's just some fluctuations going on. And so a good way to test this is we already went to the glassboard and we already have an equation, and then we could figure out what the acceleration actually was and actually find out for ourselves if it's 0. So we're going to do the same thing before. We're going to fit a trend line and we're going to see how close to 0 or if it is 0. So same thing as we did in the last plot. You could click on the data to get to the setting. It'll lead us to the same place, but I'll just show you how to do it without doing so. So the data is represented under series in this customize tab. And if we go down, you hit trend line. And then you see the line. And same issue as before, it's blue on blue. And you could kind of pick it out, but we're going to make it a different color. And we're also going to change how see-through the data points are, so it's easier to see the trend line. So as we did before, we're going to make our line thicker, change the color. I did the red the last one, so I'll just keep it red. And now this is all here for fixing up the trend line. So we just scroll up a bit. This messes with how the scatter points look like, and we're going to change the opacity. You're not fixed to these values. You could just type them in. I'm just going to ahead and do 25%, hit enter, and then there you go. And then if it does look like this on your screen where it's like filled in, I'll go ahead and click that. Remember to like click somewhere off of the data points so then you can actually see how it will look. And there we go. And then actually we need to add our equation label. Go back to series here. And you can see this line. It almost looks flat, but let's see our equation. Alright, nice. It's kind of small. Instead of zooming in like I did before, we actually could just make the font larger. Nice. We have the technology. Cool. Let's make it just bigger, just so we can. Boom. Alright, so this actually came out pretty well. It says that, remember when we went on the glass board, this term here is representing acceleration. Actually, before I even get any further, as I stated in the last plot, it says x here, but x is referring to the variable that is listed on our x-axis. So in actuality, this x should be time. It's not x position, it's time. And then as well, we would say y equals 0.19x plus 1.86. But for us, our y is actually the velocity in the x direction. So vx is equal to 0.19 times time plus 1.86. Okay, so yeah, so we broke down this equation, and we have this positive 0.19 acceleration. And something to note too, that's pretty close to 0. Like, it's not that far off, which is good. Like the logic where we're using, like gravity's only acting vertically. We're not expecting any horizontal acceleration and everything. And so this trend line that we got, this equation, is pretty good. It is close, and I am happy with the result. But something when you do data analysis, anything you have is just think about, is there anything off this data, or is there any reason why some data should be excluded from my estimate? It's always good to think about things like that. And for us here in this example, we have this interesting part here very early on in our data. Like these are the very few, maybe tens of points when we very first start our tracking. And you may remember, I'm pretty sure I explained it in part 2, but I'm going to explain it again, is that there's this thing in the tracker where, I'll just go ahead and go to the tracker. Or Also, before I get there, the reason why this might be affecting it, if you think about it, is that in these few tens of points, it starts at a low velocity in X, and then it goes up, and it goes to this 2. And so, you know, if I will say we do have a reason, I'll go talk about it in a little bit, but like this increase here could be what led to this positive slope here, indicating a positive acceleration. So this could have skewed our analysis and gave us a somewhat non-truthful actual solution. And so let me go to talking about why this data, we might be warranted to cut it out, and then we'll plot that and we'll go through that, but let's just talk about it a little more. So let me go to the tracker just to show you what I'm talking about. And so remember how our tracker works is that it only starts tracking and filling in actual data in X and Y position once it enters the green frame, the green rectangle. All right, so as this basketball's entering the frame, only a part of it is in there. And so what we're using to track the center of the ball is actually not entirely true to where the true center of mass is of our basketball. And so just by having that, there's now this bias, there's just skewness. It's having our data is getting messed up just due to the nature of how our tracker works by wanting to get the center of the basketball. And so given that, now we go back to our data, we could say that the reason why these data points here for the velocity in the X direction are down here is due to that issue. And so now that we have a reason, we can then go into our data and cut out these early points here because we actually can visually see and know that, oh, these are due to the fact of how our tracking system works. So now we look at the tracker and I explain to you why these data points and these few tens of data points early on in our data taking, we have reason to like cut them out and remove it. But before I actually show you how to do that, I want to show you that we see the same issue in our velocity in the Y direction versus time plot. This issue isn't unique to just Vx. It happened to the data for the Y position, thus it affects our velocity in Y versus time. I'll go ahead and show you that plot. I have it hiding under our Vx plot. Go ahead and bring that out. So it's hard to see a little bit. Maybe I'll zoom in a little bit. But you can see early on here we have the same issue where there's like a pretty quick change that doesn't seem actual representative of the system because it's so linear. And so this is the same issue here where we had data that potentially is affecting our analysis here. So if you want to, you could go back and make this cut and replot this, but as we saw on the glass board area, this is actually pretty good at acceleration of gravity. But if you want to be even more perfect, you go ahead and make a cut and do the same analysis. But you can see here though, just going back, is we saw the same issue that's caused by the tracker. Here we have this weird little like blip of data that's faster than, or it's pretty far out compared to the trend that we have here. Alright, so now back to our velocity and X plot here. Alright, so now let's go ahead and try to make that cut and then make the trend line again. So what you want to do is click on the plot in case you're clicking on this on your velocity in Y. Instead, click on your velocity in X versus time. Go to series. Oh, actually, no, it's not here. It's under setup. So we'll need to mess with these, but I'll just explain this before I tell you what we do. So if you remember earlier, we hit everything in column A, and then we hit Control, and then we click column D, which is for the VX. And so it selected every row. And so that's what this means. It's going from row 1 of column A all the way to row 1000 of column A. And then similar with column D. And so we want to make a cut. So this is actually tricky. This is where we want to go look at our data set and see what row do we actually want to start at to make our cut. So we're saying that the first few tens of data points, we'll see what number we decide on. These, we want to exclude these. So to find out how far we want to go, our data points first starts at about 0.15 seconds. So we're just go ahead and look at our plot. Kind of make an astute assessment looking at our axes, and maybe for sure something after 0.25 seconds. Maybe start there. It might look different. It might be somewhere around the same for your data. Remember, I did a different tracking. Your data might not look like mine, but the math and the outcome, everything will be very similar. So let's just do, we'll do like 0.25 or 0.26. We'll see what it looks like when you look at the actual time steps below. So I want to scroll down. Let's see. So we actually have 0.25. So maybe, yeah, we'll just cut up to that point and see. So what you're going to want to do is here in our, this here's the data, like what rows it's grabbing. We want to change the number that's by the lowest number, like A1 or D1. We want to change that number to something else because this tells us where we start. All right, so we're going to want to change this A1 and make it be A62. So this will be the data it first looks at. This will be the first data point now, and then it'll go forward. And similarly for D1 will need to be D62 because same row. But move over right there. So go ahead, go over here. $62. Hit enter. You saw it did kind of update itself here, but a way to know is we're affecting our plot. Nice, it looks like it automatically made that change for us. So now our data set, as we said, starts at 0.25. So everything before that time that we had data on, we decided to cut that out due to the issues of our just the inherent issues that we get with the tracking, that software that we're doing, or the tracking methodology and how it works. And it looks like it also fixes up what our trend line is automatically as well. And so now let's do the same kind of reasoning we did before. Now we have made the cut on data that we believe was an issue, and we had reasons for it. And now we have this plot because we believe this data is all good and fair because it is within our tracker frame. There's no issues of a basketball just making it into frame. So we gave the green light to this data. This is good. So this is a better trend line representation of our data. And now if we look at it, and remember this x here is representing time, and this is the function that calculates the velocity in x as it changes over time. So Vx is equal to negative 0.285 times time plus 2.26. And this term here represents acceleration, indicating we have a negative one, and this here represents the velocity, the initial velocity in x. So we now have a negative acceleration, and this just shows that the reasoning that we had earlier on cutting out these data points holds true, because this indicates that the data points that we originally had created this bias such that it had a positive acceleration. And now we took out this like the bad incorrect data, and now these data we're happy with because it was the basketball was actually within the tracker, and now we have this trend line. And so yeah, it was clear the reason that we had before, that it was making a bias, making it have this artificial positive acceleration, messing with our velocity. But now we have this -1. It's still close to 0. It's still like how we discussed earlier, but now it's saying there's a negative acceleration. So same thing before, we aren't expecting there to be any acceleration in the horizontal, in the x-axis, because gravity was working in vertical. It's only on the y-axis. So yeah, so this is the real world, and we would expect air to be there, and we would have some sort of air drag. And so we would expect a very small change in acceleration of it slowing down our basketball. So speculating, maybe that could be it. Another thing can be is just look at our data. There's a lot of fluctuations in our data, and that's just the nature of the quality of our video. Our video was somewhat coarse. On the back end, we compressed the video, any video you put into 480p, and so it's pretty small, and things just get, when a coarser, lower resolution video where the position is believed to be might be somewhat off. And a second thing, or third thing too, just speculating, could be issues that, to remember that the time we're looking, every frame is 240th of a second. And so to see any real change in X is very small, but also given that issue with how coarse the video is that wherever it thinks X is the next frame from the previous frame could cause such fluctuations. And so given that, it's maybe fluctuating about, maybe this is like 0.5, 0.3. This isn't unique to just velocity in the X direction. This also was occurring in the velocity in the Y direction. I'll get to it, but the only difference was just that there was more, we had that slope, so the range here on the Y-axis was a lot larger, so it just made it seem like the fluctuations were small. And just to show you, we'll go into our BY, and I'll just go ahead and zoom in for you so you can see that these fluctuations were not unique. So we're just going to say, let's just do 0.3. This here values that I'm messing with, the horizontal axis is messing with these values here. So we're just going to zoom in and go to 0.4. Whoa. Actually, that isn't what I want to mess with. Or, actually, yeah, maybe it is. And then let me fix our vertical axis. Minimum 0. 2.5. So yeah, there we go. So I've zoomed in on our plot here, and you can see the fluctuations kind of do, if it looks good, if you just look smaller here, you see the difference is also somewhere, it looks like about 0.5 here. So these fluctuations aren't unique to either position, so they're occurring on both of them. Let me make these back to normal. And we'll go back here. So speculating of all these issues, that could be a reason why. And another one to think on is that, these videos, we recorded them. And so if we were at like a slight angle when we recorded our video, this can create just some deviations from what the true answer is, just because we're not actually, we didn't have our camera perfectly vertical. If it was at an angle, this just changes up these values. And given all these reasons, at the end of the day, the story that's being told is just, in real life, data gets messy, data fluctuates, it's never perfect, and that's okay. That's just the nature of how it works. And so you could do the best, when you do an experiment, you do the best you can. You try to minimize any human error. You try to minimize any human error you can to help bring those deviations down. But regardless, it's probably inevitable to have any kind of fluctuation. But do your best to plan your experiment or however it is you're getting your data. And then as well, data is messy, so like we did before, consider, can I make a cut, and make sure you have a reason for the cut in your data. So, the data was pretty messy here, but we cut that out, but we actually had a reason for it. These fluctuations, we can't really, our experiment, we did as best as we could, and this is necessary because we gave the green light to this pieces of data because the basketball was actually in our tracker, and there we go. We had all the setup and things were cool. But with the data points from earlier on, was not cool data because we knew there was issues with it. All right, so let's go to our activity guide. So boom, it looks like we've made it all the way through. Please be sure to turn in your questions, or if you're just independently doing this, props to you out here learning. So everything's good. So hopefully you came to, remember, we probably have different data, but you should have came to very similar conclusions on the plots that you made and with your trend lines. But regardless, even if something was different, everything we did on the glass board to explain those equations will still hold true for your data, even if there's something funny going on. But if there's something maybe leave a comment in this video, maybe we'll check it out, or if you're something. But, thank you for tuning in. Remember all the work that we did in these, we did 3 parts. It isn't, even though we did use this video as the example, remember we have functionality in our tracker, just hitting play, where you could put in your own video. I'll go here, so I won't disappear. You could upload your own video here. You could run through the same analysis. Maybe you could beat those fluctuations. Maybe you got the perfect camera angle. See if you could get to even closer to the acceleration of gravity and even closer to 0 for velocity in the x direction. So thank you for tuning in. I hope you went through all the parts with me. Have a good one, and like I said, try out a different data set, but have a good one. Check out any other video on here on STEM coding as well if you want to see anything else. Have a good one, everybody.